The what?
The total distance around.
Yeah, I like to say it's the distance around the circle. Okay. Arc length. So we've talked about arc measure before, and it was the same as the central angle when we had the center angle, remember? And we found all sorts of other ways to find the arc measure. Here we're talking about the arc length. So arc length is just a portion or a piece of the circumference. So if you have a circle, you can draw this or not. Here's where the circumference would be going all the way around. And then if we are looking for just a piece of it, we can get just that distance as well. That's what the arc length would be if we were talking about an arc. It's not the same as the arc measure. You'll see. All right, couple of theorems you're working with. The first one you should probably know already in this point in your math career. The circumference of the circle is, do you know how to find circumference?
No.
Formula? What? Yeah. C equals 2 pi r, or C equals, what's 2 times r? What formula do you get? What? I'm hearing it. Somebody said it. No, it's no squared. 2 times r is the what? Diameter. Double the radius is the diameter, so you could also have pi times diameter. It depends on what you're given in the picture. If you're given the diameter, work with the diameter. If you're given the radius, work with the radius. Make sense? Or if you're given the diameter, you could cut it in half and work with the radius. Whatever you're given is what you use. Okay. Arc length corollary. So we have a little formula we use, a little proportion to find arc length. Arc length of, say, arc AB. Say we have arc AB. This is how you find it. 2 pi r. Yep. Isn't that the same as the circumference? Notice. Right? See that? Just pointing that out. Equals the measure of arc AB, which is going to be degrees, over 360 degrees. So let's pick this proportion apart a little bit. Once you start working with it, it's really quite easy. This ratio is made up of distance, right? This is part of the circle, and this is the circumference. Make sense? These two are, and these are both degrees.
Yes.
Okay? All right. When we start working with it, it'll be easier. All right, so then that's all from 11.4. So now we're going to start some practice problems. And then the rest of this we'll fill in tomorrow with 11.5. Okay, the diameter of a bicycle tire is 30 inches. To the nearest foot, how far does the tire travel when it makes 100 revolutions? You know me, I'm picture. I got to draw a picture. Here's a bike tire. Its diameter is 30 inches. If it's going to make 100 revolutions, that means, thinking of the circumference, which is a little bit off my circle there, it's going to rotate 100 times, correct? Yeah, so if this tire were to rotate, it would make the same distance as the circumference. Do you understand that? If your tire is rolling down, the distance one rotation makes is the distance on the road that it travels, if you think of it like that. So we're going to find that circumference and multiply it by 100. Yes?
Yes.
Okay. So find the circumference. So they gave me the diameter, so what would be the easier one to use?
30 times 5.
Yeah, it doesn't really matter, but I would use this one. Pi times 30, and you're going to use your pi button on your calculator. Don't use 3.14. Because if we all use the pi button, we'll get the same number. If we drop it off and do 3.14, we're going to get different numbers because of the rounding. So, when you did this, I got 90, well, no, what did we get? What'd you do? Give me 2 decimal places.
94.25 rounded.
Okay. Circumference is 94.25. I multiply that by 100 because that is the distance that one tire rotation travels. Are we working in inches here or are we working in feet here right now? We're working in inches.
But we want to transfer it.
Yeah, we will. Okay, so that is equal to 9425 inches. Well, I'm just going off of this. That's fine for now. Okay, now let's talk about conversion. How many inches in a foot? 12. So what do I do to this number? Divide by 12. $708, but what does the direction say?
The nearest foot, so 700.
So we have to round it.
You want to try that?
Would it be 786? I don't have the numbers in front of me.
No, it's rounds down.
Yeah, I was going to say round down.
So it would be 785. Is that what you're saying? I didn't do it. I'm trusting you guys. Okay. Make sense?
Yeah.
That's using circumference in an application problem. Turn it over. We're doing 4 of these. Okay, find the arc length of each. Find the length of each. Oh, I see what that's saying. We're going to find AB here, and we're going to find AB here. They're 2 separate problems, is what that's saying. Okay? So if we have to find arc length, we're going to use our proportion from the other side. So I'm going to write it down. The arc length of AB over 2 pi r is equal to the measure of arc AB over 360. And then we plug in what we know and what we don't know. We don't know the arc length of AB, so I'm just going to write as x. 2 pi r, what's my radius?
9.
9 times 9. What's the measure of arc AB? Right, because it's on the center, so it's the same as the angle measure. Over 360. Now, the reason I had you to get a calculator is because I want you to just do this math all in one calculation. It's pretty easy. You just do cross multiply this times this. 45 times 2 times pi times 9. See that? I'm going this cross multiply. And then I'm going to divide by 360. With me?
Yes.
What do we get?
7.1 rounded.
Let's do to the hundredths. So it would be 7.07. Let's always go to the hundredths unless it says otherwise. Okay? All right, let's do this one. We need the arc length. So I'm still using this ratio here. I don't know the arc length. Times 2 pi to the times 15, right? My radius is 15. Equals 90 over 360. All right, you get the answer there. Do it on your calculator.
Yeah.
Go to the hundredths place. What'd you get?
3.56.
It's exactly what I got. 23.56 inches. Okay? All right. Couple more to do, and that'll be it for today. Find the indicated measure. So here we have to find the circumference. Let's look at the picture and see what they gave us. They gave us the arc length, and they gave us the arc measure. So I got to find the circumference. So again, I'm going to use this right here. Okay, so what is the arc length?
6.82.
Over, I'm looking for the circumference, aren't I? So I don't know where the radius. Equals the angle measure over 360. So at first I looked at this and I'm like, oh, that's a pain. I got to do some algebra and find r. But I don't, do I? Because if they're asking me to find the circumference, this number, whatever this may be, is going to be my circumference because 2 pi r equals circumference.
Yes.
So you don't have to do that much work. You could just look at this as your x, right? Do you understand that?
Yes.
Some of you, maybe not. I'm seeing a confused look. Circumference is equal to 2 pi r. So all I need to know is this whole number right here. So do your cross multiplying. And when you do that, you get this. Right? So I did 6.82 times 360 divided by 75. 6.82 times 360 divided by 75. And this is my circumference. So just take a moment to think about that so you don't do more work than you have to. All right, I see some confused looks. All right, almost done. Measure of arc AB I'm looking for here. So they gave me the measure of arc AB right here. They gave me the arc length, which is 40. I need this angle measure right here. Okay? Because the angle measure and the measure of arc AB are the same. So I set it up the same way. I use the same ratio. The arc length is 40 over 2 times pi times 15.28, because that's my radius. Right? I don't know the arc measure over 360. I think the confusing part is keeping arc length and arc measure separate. Okay, now you just cross multiply. 360 times 40 divided by all of that stuff. What do you get? Yeah, if you round it all up, it's 150. I just went to this, but I would take either. That's it for 4.